Hi everyone. Today we're going to be looking at our notes for 7.2 sum and difference formulas for cosine and sine. Before we look at the formulas, I want to just consider the problem cosine of 105. Now, of course, we can evaluate this using our calculator, but today we're going to learn a technique for evaluating this without a calculator, finding the exact value. Okay, so the way that we're going to do this is we're going to first find two angle measures on special right triangles that add up to 105. So these special right triangles, we're referring to those reference angles of 30, 45, and 60. So we can break up 105 into its sum, 60 and 45. Okay, where 60 and 45 are special right triangles. Okay, now let's go ahead and evaluate the sine and cosine of both of these angles. So sine of 60, sine of 45, cosine of 60, and cosine of 45. So sine of 60, we can evaluate on the unit circle, is root 3 over 2. The sine of 45 is root 2 over 2. Cosine of 60 is positive 1/2, and cosine of 45 is root 2 over 2. Now we're going to use our sum and difference formulas to find the cosine of 105. So looking at this, I know that the cosine of 105 is equal to the cosine of 60 plus 45. All I'm doing here is separating that 105 into its sum here, 60 and 45. So now looking at our sum and difference formulas, let's look at our cosine formulas. So the sum formula for cosine is this first one here. Cosine A, cosine B, minus sine A, sine B. The difference formula for cosine is very similar, but now instead of subtracting the signs, we're adding the signs. So one way that I remember this is that our cosines go together and our sines go together, and the operation in between is going to be opposite that which is inside the argument of the cosine. Okay, so let's go ahead and plug this in. Remember, for the cosine ones, our cosines go together. So we have cosine of 60, cosine of 45, and then the operator in between is opposite. So instead of adding, we're subtracting these signs. So sine of 60, sine of 45. So now we can go ahead and evaluate each of these. The cosine of 60 is equal to the 1/2, and the cosine of 45 is root 2 over 2, minus the sine of 60 is root 3 over 2, and the sine of 45 is root 2 over 2. Now, if I wanted to combine these here, we would just multiply straight across. So we have 1 times root 2 is root 2, and that's all over 2. Actually, in fact, both of these terms are all over 2. We already have a common denominator. So I'm going to go ahead and combine those already. We are subtracting the root 3 times root 2, which is the square root of 6. Now, because we have different radicands here, we have square root of 2 and square root of 6. Because these are not the same type of radical here, we cannot combine these here. They don't have the same radicand. So this is as simplified as it gets. The square root of 2 minus the square root of 6, all divided by 2. Now let's consider the sine of 15 degrees. So the sine of 15 degrees, we're going to follow a similar process as we did above. We're looking for two special right triangles, those reference angles, that whose difference is 15 degrees. So I know that the sine of 60 minus 45 is equal to the sine of 15. 60 minus 45 is equal to 15. So now let's take a look at our sine sum and difference formulas. So the sum formula for sine, both of these are going to go sine, cosine, where the operator in between is going to be addition. It's going to, or at least for the sum formula, it's going to be the same as the operator inside the argument of the sine. Okay, and now here the angles will alternate. So AB and then BA. Okay. So I know that for cosine, the cosines go together and the sines go together, and the operator is opposite of what's inside the formula. Whereas in sine, the operator is the same as what's in the argument here, but then we alternate sine and cosine. Okay, so let's see how this looks for this problem here. So this would be equal to the sine of 60 times the cosine of 45, and then minus the sine of 45 cosine of 60. All right, so then the sine of 60 we already know is the square root of 3 over 2. And then the cosine of 45 is square root of 2 over 2, minus the sine of 45 root 2 over 2. And then the cosine of 60 is 1/2. So multiplying this out, we get the square root of 6 minus the square root of 2, and again, that common denominator of 2. So we have square root of 6 minus 2 all over 2. All right, go ahead and flip the page. For number 5, we want to find the exact values for the following using the sum and difference formulas. Okay, so let's consider sine of 105. The sine of 105 is equal to the sine of 60 plus 45. So this is equal to the sine of 60 cosine of 45. And then plus the sine of 45 cosine of 60. So we're alternating that sine and cosine. Okay, so the sine of 60 is root 3 over 2. Cosine of 45 is root 2 over 2. And then sine of 45 is root 2 over 2. And the cosine of 60 is 1/2. So then we have the square root of 6 plus the square root of 2 all over 2. All right. Let's check out some radians. So cosine of 5 pi twelfths. This one is a little bit tricky, but let's consider what those twelfths mean, right? And see if we can come up with the sum or difference of those special angles. Okay. So I know that 5 pi twelfths is the sum of 3 pi twelfths and 2 pi twelfths, right? 5 can be broken up into 3 and 2. Well, I know that 3 pi twelfths is our pi fourths, and I know that 2 pi twelfths is our pi sixths. Therefore, the cosine of 5 pi twelfths is equal to the cosine, I'm actually going to write out this step, so of 3 pi twelfths plus 2 pi twelfths, and that's equal to the cosine of reducing those fractions. We have pi fourths plus pi sixths. Now, I'm writing it out this time. You don't have to write it out every time. I'm just showing this for demonstration purposes. So using our cosine sum formula, we have the cosine of pi fourths times the cosine of pi sixths. Remember, those cosines go together. And then we subtract our sine. So sine of pi fourths, sine of pi sixths. So evaluating cosine of pi fourths is root 2 over 2. The cosine of pi sixths is root 3 over 2. Sine of pi fourths is root 2 over 2. And then sine of pi sixths is 1/2. So then multiplying this out, we get the square root of 6 minus the square root of 2 all over 2. All right. Letter C, sine of 345. So I noticed that this could be written as the sine of 300 plus 45. Therefore, using our sum formula, we have the sine of 300, cosine of 45, and then plus the sine of 45, cosine of 300. So alternating sines and cosines, the operator stays the same. So sine of 300, this is equal to negative root 3 over 2. Watch those negatives. This is quadrant 4. Cosine of 45 is positive root 2 over 2. Plus sine of 45 is root 2 over 2. And cosine of 300 is positive 1/2. All right, so multiplying this out, we get negative root 6 plus positive root 2. That's all over 2. Okay. All right, so number 6, prove that the given equations are identities. So let's start with this sine x plus 30. Okay, so I noticed that this is a sum here, x plus 30. We don't know what x is. X could be any other angle. But let's go ahead and write out the definition, that sum formula here. So we have the sine of x, the cosine of 30, plus the sine of 30, cosine of x. Okay, so that's the sum formula for this sine. For the cosine, so we're going to add now this part. This is the sum formula for the cosine. So we have plus the cosine of x, cosine of 60, and then minus the sine of x, sine of 60. Okay, and we want to verify that this whole thing right here is equal to the cosine of x. So let's go ahead and start evaluating some of these things. So we have sine of x, cosine of 30. Well, the cosine of 30 is the square root of 3 over 2. So this is square root of 3 over 2 sine x. Plus, the sine of 30 is 1/2. So we have 1/2 cosine x. Plus, we have the cosine of 60, which is 1/2, and then cosine x. And then we have minus sine of 60 is the root 3 over 2, and then sine x. Now let's see what happens here. I notice that we have a positive square root of 3 over 2 sine x, and then a negative root 3 over 2 sine x. These cancel each other out. Also, we have half a cosine and another half of a cosine. That gives us 1 cosine. So we verified this identity here. Okay, letter B. Here we have the square root of 2 times the cosine of x minus pi fourths. Now be careful with this. This coefficient here is multiplying the whole sum formula. Difference formula. So we have the square root of 2 times the cosine of x, cosine of pi fourths, and then plus sine of x, sine of pi fourths. Okay? And we want to verify that this is equal to cosine plus sine. Okay, so let's go ahead and evaluate what's in the parentheses. So we have cosine of pi fourths is root 2 over 2, and then we have our cosine x. The sine of pi fourths is also root 2 over 2, and then we have our sine of x. And that's equal to the cosine x plus sine x. Now when we distribute the square root of 2 into both groupings, we get square root of 2 times the square root of 2 over 2 is equal to 2 over 2, or just 1. So we get the coefficients of 1 for both terms here, cosine plus sine. And so we can see that once we distribute that square root of 2, this verifies the identity. All right. Go ahead and flip the page. Let's simplify the given expression. Sine of 75 cosine of 15 plus cosine of 75 sine of 15. So because we're alternating these trig functions, that tells me that this is a sum formula of 75 and 15. It's a sum because I know that the operator for the sum formulas are the same for sine. Okay, so this is equal to the sine of 90, which is equal to pi halves. I'm sorry, no, we're looking at the value. Sine of 90, boy, is 1. There we go. All right, so then we have for letter B, we have cosine of 5 pi twelfths, cosine of pi twelfths. So these cosines are together, and then we're subtracting our sine. So this tells me we have the sum formula for cosine. So cosine of 5 pi twelfths, and then plus pi twelfths. Okay, so 5 pi twelfths plus pi twelfths is equal to 6 pi twelfths, or pi halves. So this is equal to the cosine of pi halves, which is equal to 0. Okay. Letter C, here we have sine 3x cosine 2x minus cosine 3x sine 2x. Because we're alternating trig functions, I know that this is sine, and then we're taking the difference, so 3x minus 2x. So this simplifies to just the sine of 1x, or just sine x. And last but not least, we're alternating sine and cosine here, so this is a sine formula, and then we're taking the difference, so 4 pi thirds minus pi thirds. So this is equal to the sine of 3 pi thirds, or pi, which is equal to 0. All right. Number 8. Suppose that we have the sine of alpha is equal to 3 over 5, and the sine of beta is equal to 24 over 25, where alpha is between 0 and pi halves, and where beta is between pi halves and pi. So this tells me that angle alpha is in quadrant 1, if it's between 0 and 2 and pi halves, and then beta is in between pi halves and pi, tells me that we're in quadrant 2. So let's go ahead and draw a diagram of this. Let's start with alpha. So drawing our coordinate plane, we know that the sine of alpha is equal to 3/5, and we're in quadrant 1. So let's go ahead and draw our triangle in quadrant 1. The sine is equal to opposite over hypotenuse. So that tells me that the opposite side length is 3 and the hypotenuse is 5. Therefore, if we use the Pythagorean theorem, 3 squared plus b squared equals 5 squared, we can solve for that third side length. Now, some of you might recognize this as a Pythagorean triple. If you do, you don't have to do the Pythagorean theorem. You can just write what that value is. When we solve the Pythagorean theorem for that third side length, we find that this is side length 4. Okay, we're in quadrant 1, so that's a positive value here. Okay, this is a 3, 4, 5 triangle. And let's go ahead and label that angle as well. So that's angle alpha. Okay, so for beta, we're in quadrant 2. So let's go ahead and draw out our triangle here. And angle beta is going to be that reference angle. The sine of beta is opposite over hypotenuse, 24 over 25. Because we're in quadrant 2, we know that that horizontal component, that horizontal side length, is going to be negative. Let's use the Pythagorean theorem to find that other side length. So we have a squared plus 24 squared equals 25 squared. We get a squared plus 576 is equal to 625. So then a squared is equal to 49. And so then a is equal to 7. Now, because we're in quadrant 2, this quantity must be negative. We're going left and up to get to this point up here. Okay, so now that we have found all three side lengths for both of these triangles, we're ready to use our sum and difference formulas. So here we have sine of alpha plus beta. This is equal to the sine of alpha cosine of beta plus sine of beta cosine of alpha. Okay, so then the sine of alpha, they gave that to us. That's 3/5. The cosine of beta, looking at the triangle down here, we have the cosine is adjacent over hypotenuse, or negative 7 over 25. Plus the sine of beta, so that's actually that's given to us, 24 25, but it's also opposite over hypotenuse. And then the cosine of alpha, we look at that first triangle, adjacent over hypotenuse, or 4/5. All right, so let's go ahead and multiply this out. This left-hand term, we have negative 21 over positive 125, and then plus 24 times 4 is 96, and then over 125. When we add these up, we get 75 over 125, or that reduces by a factor of 25, so we have 3/5. All right. Now let's find cosine of alpha minus beta. So we know that the difference formula for cosine is cosine alpha, cosine beta, plus sine alpha, sine beta. Okay. So the cosine of alpha we know is 4/5. We can look at the triangle or the last problem. Cosine of beta is equal to adjacent over hypotenuse is negative 7 25. And then the sine of alpha is equal to 3/5. That's also given. And then sine of beta was also given. So 24 25. All right, so multiplying this out, we get negative 28 over 125 plus 72 over 125. So finding this sum, we get 44 1/25. And that can't be reduced. That's our answer. Okay, so number 9, suppose that the inverse tangent of 4/3 is equal to angle A and the cosine of B is equal to negative 5/13, where B is between pi and 2 pi. Okay? All right, so let's break this down. Let's start with the inverse tangent. Let's go ahead and draw our triangle. We know that the inverse tangent has range in quadrants 1 and 4, from negative pi halves to pi halves. So we know that because this tangent, this value right here is positive, we must be in quadrant 1. Okay? Tangent is opposite over adjacent, so that is 4 over 3. And then because we have 3 and 4, this is a right triangle. You might know from the last problem, a Pythagorean triple, 3, 4, 5. Okay? And then let's go ahead and label angle A as well. For cosine B is negative 5/13, and that's in between pi and 2 pi. We know that B is in quadrants 3 or 4. Okay? So because cosine is equal to a negative value, between those two, we know that it's got to be quadrant 3. And we know that cosine is adjacent over hypotenuse, so that tells us that the adjacent side is negative 5 and the hypotenuse is 13. Okay, because we're in quadrant 2, that horizontal component, quadrant 3, that horizontal component is negative. Now, if I wanted to find that third side length, we can use Pythagorean theorem. And again, you could probably recognize that this is a Pythagorean triple. But let's go ahead and solve for it. So we have 25 plus b squared equals 169. B squared equals 144. So then b equals 12. Now, because we're in quadrant 3, this quantity is negative. Okay, part A, we have sine of A plus B. Oh, let's label angle B. There we go. So this is equal to the sine of A cosine B plus sine of B cosine A. Okay, so sine of A is equal to the opposite over hypotenuse. So that first triangle, opposite over hypotenuse, is 4/5. Cosine of B, second triangle, we're looking at negative 5/13. In fact, that one was given to us. Adjacent over hypotenuse. So sine of B is opposite over hypotenuse, so negative 12/13. And then cosine A is adjacent over hypotenuse in that first triangle, 3/5. So when we multiply this out, we get negative 20 over 65. And then plus, we get negative 36 over 65. So finding this sum, we get negative 56/65. All right. Cosine of A plus B. So here we have the cosine of A. Cosine B. Let me erase that. There we go. So cosine A, cosine B. Here we go. And then minus sine A, sine B. So this is equal to, well, cosine of A is the 3/5. Cosine of B is negative 5/13. Minus sine A is 4/5. And sine B is negative 12/13. So this is equal to, we get negative 15 over 65, and then minus, we get a negative 48 over 65. So subtracting a negative, we can make that both positive, adding a positive here. So 48 plus negative 15 would be 33/65. Okay. All right, let's go ahead and flip the page. Last page here. So we have sum and difference practice. Evaluate the cosine of the inverse sine of 24/25 minus the inverse tangent of negative 3/4. All right, so let's go ahead and draw these triangles. Let's start with that inverse sine. So we're looking at inverse sine. Remember, the range of the inverse sine is quadrants 1 and 4, but we have a positive value, so we know we're looking in quadrant 1. So we have 24/25 opposite over hypotenuse. Okay, so if we wanted to find the third side length, from the earlier problem, I know that this is a Pythagorean triple, 7, 24, 25. But again, you could use the Pythagorean theorem. All right, let's call this angle A. And then for the other part, we have the tangent, inverse tangent of negative 3/4. Remember, the range of the inverse tangent is quadrants 1 and 4. So therefore, because tangent is negative, we must be in quadrant 4. So we have a negative 3 on the opposite side and a positive 4 on the adjacent side. Again, a Pythagorean triple, so the hypotenuse is 5. Let's go ahead and label that reference angle as angle B. So this is the same as finding the cosine of angle A, that first triangle, minus angle B. Okay, so then this is equal to the cosine of A and then cosine of B plus sine of A, sine of B. So the cosine of A is equal to adjacent over hypotenuse, 7/25. Cosine of B is adjacent over hypotenuse, 4/5. And then plus sine of A, which is 24/25. And then sine of B is negative 3/5. Okay. So multiplying this out, we get 28 1/25 plus 24 times negative 3 is negative 72 1/25. And then adding these up, we get negative 44 1/25. All right. Number 2, find the exact value. This is pi 12th, so I know that this is the difference of pi 4ths, or 3 pi 12ths, and pi 6ths, 2 pi 12ths. Okay. So let's go ahead and set up our formula. So we have the sine of pi fourths, cosine of pi sixths, minus sine of pi sixths, cosine of pi fourths. So this is equal to root 2 over 2 times the root 3 over 2 minus 1/2 root 2 over 2. So all in all, this is equal to root 6 minus root 2 all over 2. Okay. Cosine of 75 is equal to the cosine of 30 plus 45. So this is equal to the cosine of 30 cosine of 45 minus the sine of 30 sine of 45. So that's equal to the cosine of 30 is root 3 over 2, cosine of 45 root 2 over 2, sine of 30 1/2, sine of 45 root 2 over 2. So this is equal to square root of 6 minus square root of 2 all over 2. All right. Number 3, find the exact value of the expression sine of 10, cosine of 50, cosine of 10, sine of 50. That's plus there. So then I know that this is a sum for a sine. So sine of 10 plus 50, this is equal to the sine of 60, which I know to be root 3 over 2. Okay. All right, so last problem here. Evaluate the cosine of x plus y, where sine of x is 7/25 in quadrant 1, and cosine y is negative 20/29 with y in quadrant 2. So let's start by drawing out x, the triangle that contains angle x. Quadrant 1, so drawing our triangle here, where we have opposite over hypotenuse, 7/25. So then, again, a Pythagorean triple, that third side length is 24. And our angle is x. Our triangle in quadrant 2, let's go ahead and draw that. The cosine is negative 20 over 29, adjacent over hypotenuse. Let's find that third side length, so using the Pythagorean theorem. And again, you probably will recognize this as a Pythagorean triple. We get 400 plus b squared is equal to 841. So then b squared is equal to 441, or 21. And we're in quadrant 2, so that vertical component is positive. Okay, so then the cosine of x plus y is equal to the cosine of x, cosine of y, minus sine x, sine y. So the cosine of x is equal to adjacent over hypotenuse, 24/25. Cosine of y is equal to adjacent over hypotenuse, negative 20/29. Minus sine of x is 7/25. And sine of y is, we didn't label y, is equal to opposite over hypotenuse, 21/29. Multiplying this out, we get negative 480 over 725. And then minus 147 over 725. And finding that difference, we get negative 627 over 725. All right. All right, so this has been our notes on sum and difference formulas for sine and cosine. We're going to get a lot of practice on this, so we'll see you tomorrow. Goodbye, everyone.